Hello and welcome to Embedded Junction. I am Mohammed Hussain, working as a senior engineer in an automotive company, and I am here to provide some basic training on embedded systems and C programming language. As these both topics are interrelated, they are very well connected to each other, so there will be two separate parallel videos going on, one on embedded systems and one completely on C programming language. So today it's the first class, very first class, so maybe it's a mix up of both the things, and it's the introduction of the embedded system. So I have listed out the topics here which I have to cover today, and so first of all let's discuss about the embedded systems introduction, that what embedded system is. You might have heard about the word embedded, maybe in your academics or anywhere. The word embedded itself means when an object is firmly fixed into some surrounding mass, it is known as embedded. So let's say if this is a surrounding mass and an object is fixed inside it, is fixed inside that object. So this is known as embedded. Now in embedded systems, what I am talking about, the surrounding mass is actually the hardware, and the object what we fix into it is a software. So we can define the embedded system in our own way, that embedded system is a combination of hardware and software to perform a desired task. So there are so many examples like your mobile phone, TVs, laptops, CD players, washing machines. So list is endless. There are so many embedded devices that at an average you are surrounding with. So with the definition of embedded systems, there comes the introduction of hardware and software. So let's talk something about hardware. You all know that our laptops are equipped with some microprocessors, which are namely Pentium 4 or Core i3 processors, dual core, and this in mobile phone very commonly we use Qualcomm Snapdragon, and there are so many chips that a mobile phone uses, and so many other processors are there. So I am assuming that you have a prior knowledge of microprocessors, and I am not going into the depth of microprocessor architecture. I will just give a brief overview. So hardware, this is the hardware I am talking about, a microprocessor. A microprocessor is a single silicon chip which has internally so many components, like we have some registers. It's hard for me to write everything, so it's registers, general purpose registers. You have a program counter, and you have something like stack pointer, you have something like instruction decoder. There's some fetching list, and there's of course one ALU is there, arithmetical and logical unit is there, instruction decoder circuitry is there, a lot of component. I am not describing everything inside here, but it's just a brief overview. And if you have seen any architecture of a microprocessor, then you can recall all those things, or if somebody wants, I can share that in a separate video also. So this is how a microprocessor looks like, and so to the external world, there is the memory. Okay, here's the memory. Let's say this is the RAM. Okay, and the microprocessor has something like address bus and data bus. So address bus and data bus, we interface with the memory, whether it is a RAM or a flash memory or a ROM, and definitely we need another interfacing circuitry to interface this memory to this. And let's say if your program is in the RAM, it is your program is getting executed from the RAM. The program counter job is to store the address of next instruction. These are very basics of a microprocessor, and you might feel that I'm going too fast, but if you want me to share this video, then definitely I'm gonna share a complete section on this part also. As I told, the microprocessor needs some memory to operate. So here's the memory. Definitely, if we use these processors and controllers, we deal with the input and output pins. So we have something like general purpose input output pins, and for interfacing those pins, we again have some like PPI thing. Peripheral programming interfaces are there if you need SPI like serial peripheral interface, or you need, there are so many peripherals which are needed to perform some task in embedded systems. So this is how your system looks like. That a microprocessor talking to the memory and talking to all other peripherals attached to it. There are so many peripherals attached to a microprocessor. Now I talk about microcontroller. Microcontroller is nothing but the combination of microprocessor, memory, and all the peripherals is a microcontroller. So there is no need of external memory. There may be a need of external memory when your internal memory is not sufficient. But these controllers have all the components necessary to perform the minimum task. And there's memory, there's peripheral like SPI, UART, so many protocols like I2C, and you have GPIO, you have interrupt controller also, you have DMA. So many things, so many components are there in the microcontroller. This is a very brief diagram of a microcontroller, and this is the hardware. Now let me talk something about software. As I discussed, microcontroller has inbuilt memory, and it's not the correct time to discuss whether it's RAM or ROM. Both are present. Let's say your code is getting executed from some memory. So at the lowest level, the software is nothing but the instructions. Instructions given to this microprocessor or the microcontroller to perform a desired task. Suppose 01 is the instruction which is very meaningful to this microcontroller, and which means to add two numbers. So maybe 01 followed by 02 and 03 means that add 2 and 3. Okay, 02 can be again a meaningful instruction to move something, to move from one register to another. So like this, we have so many opcodes, we have so many mnemonics present in the datasheet of the microcontroller or the reference manual of the processor. If I talk about these instructions are in actually binary language. These are in the forms of zeros and ones. So it's very difficult for a programmer, it's very hard for us to write a complete code, a complete sequence in these instructions, in this opcodes, because they are all in binary in the zeros and ones. So there comes the introduction of an assembler or assembly level language. Assembly level language is not a high level language, but I can say it's a middle level, but with some mnemonics which are easily understandable by a human programmer. So okay, I can make it this way. Let's say it's move a comma b. So this assembler knows that this move a comma b is nothing but the instruction 02. So assembler converts these mnemonics into opcodes, and this language is known as assembly level language. So as you have seen, this assembler is very much dependent on the this mnemonics. That's why this assembler is very much specific to a microcontroller. Maybe Intel has its own assembler, ARM has its own assembler, and different controllers and manufacturers uses their own assemblers. So there is no reusability of this assembly language. So I have told you about opcodes and assembly level language. You might feel that I have skipped so many things inside, maybe the architecture of the controller or the opcodes or assembly. if you find anything is missing or you want some more detail, please write a comment in this video, and I'll share the video. Definitely, I'll share one more video with you. And with assembly level language, the last point what I told, the assembly level language is not reusable. Let me give you an example. Let's say there is a hardware A which is manufactured by any company like Intel or any other company, and you have another hardware which is manufactured by another company. Now one company, one bank, or any company starts writing a program on this hardware, and they start writing the program in assembly level language. It took, because software development is not an easy process, it takes years also, so they took maybe 2 years to complete this project, all in assembly level language. But in 2 years this hardware is outdated. There is another hardware available in the market now which is more faster than it, maybe with the reduced instruction set, and so many other advantages are there of using this hardware now. So this cannot be ported now. This assembly code cannot be ported to this because they both belong to different manufacturers. They both belong to different family. Comes the introduction of C language. As you have seen that the software was written in assembly level language and the porting was not possible. But if you write your program in C language, the reusability is very high, and obviously you can port this piece of code in any other target hardware. There is no hardware dependency in C language. C is a high level language, it uses 32 keywords I think, and as I told, this is a mix up video, so here it's just the intro of C. In my next videos I am going to show you in detail that about the keywords, data types, operators, pointers, functions, and so many things. So with C, it again comes some dependency on operating system. C as a language, okay, let me put it this way. While writing the code in assembly language, to convert it to a binary file or opcode file, you have used an assembler. Similarly, if you have written a code in C, you need a compiler. If you have written a code in C, you need a compiler to convert it into the machine level language code. And every OS has one compiler. Linux has its own compiler. Windows has its own compiler. So there is a dependency on operating system now. In my next videos, I am going to show you the C code or the compilation stages and everything, but to give a brief overview, let me tell you, if you have a C file, okay, let's say you have some 1.c, and this big box is a compiler. So compilation or compiler is again not a single step, it is a sequence of steps, it has multiple steps involved. So first step is the pre-processing, okay, then next step is the translation, or sometimes we call it actually compilation also. Then we have an assembler, we have a linker, and the output of this will be very much platform dependent. If you are working in Windows, then you will get 1.exe. If you are working in Linux, then it will be a.out. Actually in Linux there is no concept of the extension name for executable file. You can name as you want. If it's a cross-platform development for like our embedded systems. For embedded systems, we are developing the applications which are cross-platform compilable, and the development process is known as cross-platform development because we compile the code in Windows machine and we download the code on a target hardware which is of some other manufacturer. So the cross-platform output is the binary file, the hex file, which has nothing. All of these have nothing but the instruction set. Sorry, all of these have one thing in common, which is the instructions of the microprocessor. And exe and a.out are actually the because they have an operating system associated with it, so there is some more information loaded to make this as exe or a.out. That information is not present here in one.binary or one.hex. So that's very much operating system dependent executable file. So in general, all of these files have instructions, the opcodes of the microprocessor loaded, and using this compiler, we can convert a C file into a hex file or binary file. In my next videos, I will show you that what each stage does, and what are the importance of all the four stages. And similarly, in embedded systems, I will share about the different types of microcontrollers available in the market, and how to program the microcontroller. If possible, I will show you the practical videos also. And similarly, in C, I will try to share my laptop screen with you guys. So that's all for today. Thank you for watching my video, and if you have any questions, please comment in this video, and I'll be giving you the answer. And if you like this video, or if you don't like, please give some feedback so that I can make it more helpful. And please share these videos, because there are few people who have not enough resources to read all these things by themselves. So please share as much as possible, and let this video reach to those people who need it. Thank you for watching. Thank you.